A.REI.3. This is reasoning with equations and inequalities. We have spent some time talking about solving equations in this standard, and today we are going to jump into the inequality portion, just using addition and subtraction. We'll be getting to multiplication and division in another video that I'll be doing. Terms to know. In the blue, I have some additional terms from our previous list when we were solving equations. Please pause the video and write those down in your notes in your journal. Okay, the first example, it says x plus 4 is less than 5. And what we're trying to find is a value or many values that when added to 4 will make the statement true. So what numbers do you think right off the bat can you think of in your head that make the statement true? Okay, maybe you came up with a few. I want you to know that solving inequalities is going to be just like solving equations. So I'm going to take this equation off to the side here and just use an equal sign instead of the inequality symbol. So we're saying x plus 4 is equal to 5. And we thought what number added to 4 would make this equal. So we would have two sides of the equation that were equal to each other. So we took a value, added it to 4, and we came up with x. We used the inverse operations as a method to solve this. So we subtracted 4 from both sides, and I think I did it horizontally. I'm going to do it vertically right now. I know you guys like to do that. So I take x, subtract 4 from 4, we get 0, and that is equal to 1. Well, we're going to do the same thing with the inequality symbol, and then we're going to look at the answers that might make that statement true. Let's clear that off. So if I have the same process and I say, okay, subtract 4 from both sides, I'm going to come up with x having to be less than 1. So what they're saying is that any value that you choose for x has to be less than 1 when substituting in for this value so that the inequality symbol is true. So let's check that out. If x is less than 1, what number can you think of off the top of your head that is less than 1? How about 0? So is 0 added to 4 less than 5? Well, 0 plus 4 is 4, and 4 checks out. 4 is less than 5. So I know that 0 would be one of our answers. How about taking 1, the value that we actually came up with in our inequality? Let's check out 1 and substitute it in. So I'll substitute in 1, add it to 4, and see if it is less than 5. Well, 1 added to 4 is 5. And is 5 less than 5? This is a no. So I know that 1 is not an answer. I know that 0 is. So let's take 1 on our number line, put it right in the middle, take a value that is less than 1, which was 0. It worked. Take a number greater than 1, which could be 2, and let's check its value. So 2 plus 4, is that less than 5? So 2 plus 4 is 6. Is 6 less than 5? Here is another no answer. So when we're graphing the answers, we want to make sure that we take into consideration all of the values that make the statement true. So we look at a number line, and we go to the number in question, which is 1. I like to put that right in the middle. This is the number in question that we're working with. And we're going to put an open circle on that 1 because it's not included in our answer. But all of the numbers that are less than 1 will work. So we shade in the arrow and the number line leading up to that open circle. Second example. Solve it the same way that you would an equation. Pause the video, go ahead and try that. Okay, so we're gonna do the inverse operation of subtracting 6. which is adding 6. And we're going to do that to both sides. So we have x is greater than negative 10 plus 6, and that would be negative 4. So the number in question is negative 4. The number smaller to the left would have to be negative 5. Remember, the numbers as you go to the left on the number line get smaller. Even though they look like they're increasing in size, they're actually getting lower and lower. You can think of it in terms of money. You're losing money. You lost $4, you lost $5. You're losing more and more. You're getting smaller. You can think of it in terms of temperature. If it's cold outside, you'd rather be in a negative 4 degree area than a negative 5, because obviously it's just a little bit colder. And then to the right of it, let's make it a little larger than negative 4, which is negative 3. So let's go check the numbers that are either to the left or to the right of our number in question. Our number in question, again, is negative 4. So let's just go run a little quick check. Let's check negative 5. If I take negative 5, according to the inequality on the left, and then I subtract 6 from it, is it greater than negative 10? All right, so I lost $5 and then I lost 6 more. So we have negative 11. Is that greater than negative 10? Well, again, think of it in terms of, I guess, the temperature. If it is negative 11 degrees outside, is that greater than or warmer than negative 10? So this is a no statement. So negative 5 would not work in this inequality. How about another sample? Let's just check negative 3. Negative 3 take away 6. Is that greater than negative 10? So I lost 3 and then I lost 6 more, so I'm at negative 9. Is that greater than negative 10? And that is a yes. Negative 9 is greater than negative 10. So I know that negative 3 is going to work. And just for kicks, let's try the number in question. I already know that the symbol says it's not equal to it, but let's just check it anyways. So is negative 4 subtracted by 6 greater than negative 10? And that is a no, because negative 10 is not greater than negative 10. So it's not going to be included in the answer. So what I do by answers not being included is on the number in question, again, I put an open circle on negative 4, and then I think which were the numbers that were going to work. And we said that all of the numbers that work to the right side of the negative 4 will work when we plug them into our inequality. All right. Negative 8 is less than or equal to 8 plus x. So solve it like a regular equation, and then we'll plug in or talk about the inequality symbol. Looking at the sign in front of the 8 on the right side, it is a positive 8. So to get rid of that, we're going to subtract 8. So we have negative 16 is less than or equal to x. Now, I picked this problem on purpose because sometimes you're going to see the x variable or whatever variable you're using on the other side of the inequality symbol. So this reads from left to right, negative 16 is less than or equal to x, or in other words, some value of x is bigger than, if you read it from right to left, x is greater than or equal to negative 16. So I prefer, just for my own sake, to kind of turn this around, and that might get a little confusing when we get into multiplying and dividing by negatives, because we're going to be talking about moving this inequality symbol around. But I like to have the x variable first. So if the symbol is open to the x, I'm going to open it to the x and just kind of turn the problem around. So now it reads, x is greater than or equal to negative 16. Our number in question is negative 16. The number to the left would be smaller, which would be negative 17. And the number to the right would have to be negative 15. So let's go check all three of those. I think the easiest way to make sure that you are correct in these inequalities is to check the number in question and then the number to the left and to the right, just to make sure. All right, let's check negative 17. Okay, is negative 8 less than or equal to 8 plus negative 17 is negative 9? So read it from left to right or right to left, however it's easier for you. Is negative 8 equal to negative 9? Well, that's a no. Is negative 8 less than negative 9? That is also a no. So I know that the negative 17 is not working for us. Let's try the negative 15. So is negative 8 less than or equal to negative 7? So is it equal to? No. But is negative 8 less than negative 7? Or in other words, is negative 7 greater than negative 8? And that is a yes. And the third and final one is our number in question, and that's the number that we have figured out through our inverse operations. So let's check out negative 16. So is negative 8 less than or equal to negative 8? Well, yes, of course it is. Negative 8 is equal to negative 8, so it satisfies one of the options, so we have a yes. All right, now when we graph this on our number line, we know that now negative 16 is part of our answer. So instead of that open circle that we were talking about, we're actually going to fill it in now because it is included in the answer. And the other answer that was included was the negative 15, which was the options to the right. All of those numbers, including these decimals in here. It's important to note that, you know, negative 15 and a half would work, or negative 15 and 9/10 over here would work. So all these decimals, including negative 15, and then you color in the arrow to make sure that it's all of the numbers to the right and their decimals. Okay, last one. It says x plus 5 is less than or equal to negative 8. Solve it like an equation. The opposite of adding 5 is subtracting 5. So x is less than or equal to negative 13. That is our number in question. We have negative 14 on the left and negative 12 on the right. Why don't you go and pause the video and check all three of these options for us. Okay, so let's start with negative 14, which is the smallest number on the number line that we have here. So is negative 9 less than or equal to negative 8? Or if you like to read it the other way, is negative 8 greater than or equal to negative 9? Yes. Let's try the negative 12. Is negative 7 less than or equal to negative 8? No, that is not a true statement. And now the number in question that we like to check, just in case we have to include it in the answer, we like to check that number that comes up in the inequality over here in our original problem. All right. Is -8 less than or equal to -8? Of course, they are equal to each other. So in the final answer, we are going to put what type of circle? Are we going to have an open or a closed, shaded in? Well, since there's that equal sign underneath the inequality symbol, we're going to shade it in. It is included in the answer. And then the -14 that we started with satisfied the inequality, so we are going to shade now to the left. Final answer. Okay, we have completed solving inequalities using addition and subtraction. There will be another video coming that will include solving inequalities with multiplying and dividing. I will also in class make sure that you understand how to use decimals and fractions and mixed numbers with these inequalities. I didn't put any on the video because the main thing I wanted you to know is how to solve first regular inequalities with whole numbers, because the graphing part is mostly where the students have some of their mistakes. So in your journal, please define the new given terms. If you learned anything new, please write that down, share it with the class. And if you had any questions or confusions, see me in class or talk with your friends and we'll figure that out.